Okay, so we're going to do just the first 12 problems from the final exam review tonight, and then we'll do the remaining problems, on Thursday. So we're going to start here, and this is just a review this is the same review that is in Hawks under your web test for the college algebra class. It's just a version of it printed out, and you can get this version on the announcement. So we're going to start with section 2.6, and what we're going to do first is we are going to solve this radical equation. Remember, in order to solve this, we have to take this minus y and move him to the other side since he is outside of our square root. So we're going to do this by adding y to both sides. I'm actually going to come up here so I have more room to this for this problem. And this, we're going to have the square root of 196 minus y equal to y plus 14. And then to get rid of the square root, we are going to square both sides of our equation, just like such. Remember, the square root and the square are canceling each other out. So we have 196 minus y equals, and we're going to FOIL this by multiplying it times itself, so y plus 14 times y plus 14. So now we have 196 minus y. When we FOIL, we get y squared. Remember, FOILing just means first, outer, inner, and last. So this would be y squared plus 14y plus another 14y plus 196. So now we want to move both this 196 and minus y to the other side so that we can factor. So we're going to subtract 196 from both sides. And what's going to end up happening is they're actually both going to cancel out. We're going to add y to both sides. So now we have 0 equals y squared. And then remember, when you do this, you're adding 14y plus y. So our 14y, and then plus y. So 14 and 14 is going to give us 28, plus one more is going to give us 29. So this will be 29y. Now, you can use the quadratic formula to solve this. It's much easier if you'll just factor out a y. So this would be 0. We would take a y out front here. Well, and I want you to think about this. If this is y squared, which is y times y, and I take away one of them because I put it right here in front, I still have one left. So that would be y plus. And if I take away that y from the 29, I still have the 29 left over. And so that's how that's going to factor. And I should be able to distribute that y back and go y times y gives me a y squared. Y times 29 gives us 29y. So we should be able to go backwards. Now what we're going to do is take each piece, set it equal to 0. So we have y equal to 0. We have y plus 29 is equal to 0. So over here we're going to subtract that 29 from both sides. Oops. And we're going to get y is equal to negative 29. Now remember, whenever our problem has a square root, before we can say our answers are 0 and negative 29, we do have to check and make sure they are correct. So I'm going to come over here to this side up here. I'm going to use, let's do it with purple. We're going to check our answer for number 1, and we're going to start with 0. So we're going to say the square root of 196 minus 0 minus 0, and we want to know, does that give us 14? That's our question. Well, the 0 and the 0 cancel each other out, or not cancel out, they just go away because 196 minus 0 is still 0. Still 196. Sorry about that. So this will be the square root of 196, which is indeed 14. So 14 equals 14. That is correct. So we know that this answer is right. But now we've got to do the same thing with the negative 29. So we're going to check that one. So we're going to do the square root of 196 minus a negative 29. And then on the outside, minus a negative 29. We want to know, is that going to give us 14? Well, if you remember, two negatives in a row here and here are going to make that positive. So we're going to have the square root of 196 plus 29 plus 29. And then this is going to give us the square root of 225. The square root of 225 is 15, and 15 plus 29 does not equal 14. So this answer is not a solution. So our only answer here is 0. And again, remember, anytime our problem has a square root, we have to come over here and check our answers to make sure that they both work. And most of the time, one of them is not going to work, just kind of as a side note. All right, so question number 2 here. This time we're working with a cube root. Our cube root is all by itself. So the way we're going to reverse that is we're going to take this and we're going to cube both sides of it. So our cube and our cube root are going to go away. So now we have 5y squared plus 6y equals 2 cubed, which is 2 times 2 times 2, or 8. We're now going to subtract that 8 from both sides, so everything is on the side with our y squared. So we have 5y squared plus 6y minus 8 is equal to 0. And really the only way we can solve this, or that we know how to do, is the quadratic formula. So we're going to start off with a being 5, b is 6, c is negative 8. Okay, so we're going to use our quadratic formula. I'm going to come over here to do that. So x equals negative b, so that's negative 6, plus or minus the square root of 6 squared minus 4 times 5 times negative 8 all over 2 times 5. All right, so this would be negative 6 still, plus or minus the square root of 36. This is going to be a positive since we are doing a negative 4 and a negative 8. So 4 times 5 is 20. 20 times 8 is 160 over 10. Just keep going here. So negative 6 plus or minus the square root of 196 over 10. We actually just did 196, that's 14. So this is negative 6 plus or minus this 14 over 10. And remember, at this point, we got to split it up. Negative 6 plus 14 divided by 10, and negative 6 minus 14 divided by 10. So this is going to give us 8 over 10, which is going to reduce down by 2 and give us 4 over 5. So there's one answer. This second one, that's going to give us negative 20 over 10, which is going to reduce down to negative 2. Because this was a cube root, we don't need to check these answers. Our answers are going to be y equals 4 over 5 and negative 2. Okay. And again, the reason we didn't have to go back and check on these is because we are working with a cube root, so we don't have to worry about it as much there. All right, so question number 3 is out of section 4.1, kind of going back to the very beginning of the semester here. So we're going to start off with, we're going to rewrite as a relation as a function of x, of f of x. This means that we need to solve for y. Guys, as we're going through this and I'm highlighting things with the blue color and writing information in the green, if you have a hard time knowing what to do with a problem, then what I'm doing right now with the highlighting the instruction and then telling you what in green what it means, this would be a really good thing to put on a note card. Like you could put rewrite as a relation or rewrite as a function of x, and on the back side just put solve for y. So it just gives you an idea of what you're supposed to be doing on problems as you're going through. All right, so let's take this guy. Negative 2x minus y is over 3 is equal to negative 6. We're going to start off by getting rid of that 3 in the denominator, so we're going to multiply by 3 on both sides. So over here on the left, my 3's are going to go away. So we have negative 2x minus y equals a negative 18. We are solving for y, so we're going to add 2x to both sides. So we have negative y is equal to 2x minus 18, or if you put the negative 18 first, that's perfectly fine. And then we're going to divide everybody by negative 1. And basically all this is going to do is change our signs over here. So we're going to get y equals a negative 2x plus 18. And that's going to be our answer here, negative 2x plus 18. Now what we're going to do for the second part is we are going to evaluate when x is equal to 1. Remember, evaluate just means to substitute in. So sub in for x. So if we go back to our original equation here, we're going to do negative 2 times 1 plus 18. So negative 2 plus 18 is going to give us 16. So that's our answer for step 2 is 16. All right, so this next one is asking us to determine the implied domain. So when we do implied domain, we have a couple questions to ask ourselves. So question number 1 is there a square root? Okay, if we answer yes to this question, we set the underneath greater than or equal to 0, and typically our domain ends up being a bracket with some number to infinity with a parentheses. The second question we're going to ask ourselves is there an x in the denominator? Okay, if we say yes to this question, so we said yes to this, then we're going to set the denominator equal to 0. And our interval notation is going to be with a union. It's going to go from negative infinity up to a number with a parentheses, unioned from a number to infinity. So those are kind of our two options. There are two questions you need to be able to, when you see implied domain, be able to remember these two questions and what you're supposed to do. Now remember, if you answer no to both, then that means your domain is all real numbers. Okay, so for this particular problem, if I go back up here and I look at my answer here, and I ask myself, is there a square root? I'm going to say no, there's no square root. Is there a variable in the denominator or an x in the denominator? She's saying no because there isn't even a denominator in this. So since we said no to both questions, then my domain is going to be all real numbers. So right here, we're going to put all real numbers. If you don't like to do the r, remember you can always do negative infinity to positive infinity. I'm just lazy and like to use the r for mine. All right, so let's keep going. So number 4 is asking the exact same question. It wants to do the implied domain of the function f of x equal to the square root of x plus 3 plus 7. So remember, when we're doing this, we only care about the underneath. So we only care about this guy right here. So we're going to take that, x plus 3, set it greater than or equal to 0. So we're going to solve for x. So I subtract that 3. So x is greater than or equal to negative 3. Since it is greater than, that means it's going out to the right. So it means we're going to start at negative 3. Oops, that's not a negative 3. Try that again, Amy. How about negative 3? And it is going to go out to infinity with a parentheses, and this would be our domain. Okay, and remember, if you're having a hard time doing the interval notation directly from the algebraic notation or from the symbol here, then draw yourself a number line. Here's your negative 3, and if I'm going out to infinity, then, or if I'm going to be bigger than negative 3, that's that direction. And then because we said or equal to, we do a bracket, and then that might help you see how we got that answer. So remember, you can always do a really quick draft of what it should look like. All right, so the next question we have is from section 4.2a. So we're going to find the vertex. So first find the vertex. This particular problem is in what we call vertex form. Vertex form is when we have f of x equal to x minus h squared plus k. And our vertex for this is going to be h, comma, k. Remember, we're going to do the opposite of whatever sign is for the h, and we're going to keep the sign on the k. So in this particular example, our h is going to be 4. Again, doing the opposite of that inside. So our h is going to be 4. And our k is going to be -5. So it's -5. And that would be our answer there. So in that vertex form of finding your vertex is really easy when it's in this particular form because the numbers are just right there. You just have to pick them out. And always remember it's opposite of your h value. Okay, so now when we talk about finding the x-intercepts, so anytime we talk about this, we're going to set the equation equal to 0. So that means we're going to take this guy and we're going to say 0 equals x minus 4 squared minus 5. We're going to get this into a format where we can either factor or use the quadratic formula. So we need to multiply this out. So 0 equals x minus 4 times x minus 4, and then minus 5 on the end. So 0 equals x squared minus 4x plus 16, and then minus 5. And then we just need to combine like terms. So we've got our -4x's there that we're going to combine. We've got our 16 and 5 that we're going to combine. So 0 equals x squared minus 8x plus 11. And this guy does not factor. There's no factors of 11 that will add to 8 because the only factors of 11 are 11 and 1. And 11 plus 1 would give us 12, so not 8. So we are going to have to use our quadratic formula in order to do this problem. So I'm going to come over here and do this. Our a is going to be 1, b is going to be -8, c is 11. So x equals a positive 8 since it's the opposite of our 8 value, plus or minus the square root of 8 squared minus 4 times 1 times 11 all over 2 times 1. So we have 8 plus or minus the square root of 64, and then 4 times 11 is going to give us 44 over 2. So this would be 8 plus or minus the square root of 20 over 2. And then because we are looking for an exact answer here, we're going to break this 20 apart and see if we can get anybody out of prison. So we're going to have 20 and 10. This is 2 and 5. So a pair of 2's gets to come outside. Remember, only one of them gets to break out. So we have 8 plus or minus 2, and then our 5 is left underneath. So square root of 5 divided by 2. And then what we need to do here is reduce in the v. So this will be 4 plus or minus the square root of 5. So we do have 2 answers here. I don't know if I can fit it all in this little space that it has for me, but I have 4 plus the square root of 5, comma 0, and then 4 minus the square root of 5, comma 0. Okay. So step 3 is to find 2 points. Remember, when we're finding points, this means we get to pick a value for x and plug it in to find y. All right. Now what I'm going to do here, since my vertex was 4, I'm going to subtract 1 and I'm going to use 3. And then I'm going to add the same amount. I'm going to add 1 and use 5. So the x's that I'm going to pick down here for my 2 points right here, I'm going to pick one of them to be 3 and one of them to be 5. And the reason I'm doing that is because if I pick 3 and 5, I only have to plug in one of them, because my y value will be the same for both of them since they're equal distance from my vertex. All right, so let's plug in 3. So we're going to do t at 3 equals 3 minus 4 squared minus 5. So 3 minus 4 would be negative 1 squared minus 5. Negative 1 squared is going to be a 1 minus 5, which is going to give us negative 4. So our y value here is negative 4. Again, if you don't believe me, you can do it, but we can do the same thing and plug 5 in. We'll also get negative 4. Remember that these graphs are symmetric, so whatever happens to a point that's 1 less than my vertex, the same thing happens for a point that's 1 more than my vertex. So we're going to graph our vertex, which is to the right 4 and down 5. Be right there. We're going to graph 3, negative 4, so to the right 3 and down 4. And we're going to graph 5, negative 4, to the right 5 and down 4. Oops. And then we're just going to draw our parabola. And the reason we didn't graph our vertex or our x-intercepts is because they were really funky numbers. So we used the extra 2 points to be able to do that. And that is our problem there. All right, so question number 6 is also out of 4.2, and we are going to do basically the same concepts. Again, we're going to start off by finding the vertex. However, in this one, it is in what we call standard form. So standard form just means it's in the factored out version, the ax squared plus bx plus c. So to find the vertex in standard form, you have to do negative b over 2a, and then f at negative b over 2a. And remember that all this second part means is that you're going to find the first one and then stick that into the formula to see what you get. So starting off, we're going to do, we're going to do negative b over 2a. And for our problem up here, a is going to be 1, b is going to be 7. So we get negative 7 over 2 times 1, or negative 7 halves. So there's our x value, negative 7 over 2. And again, we're going to take this value right here, and we're going to stick it back into our equation up there. So we're going to get rid of our y, we're going to go q at negative 7 over 2. So this is going to be negative 7 over 2 squared plus 7 times 7 over 2 plus 12. Now we can go through the whole process of how you would simplify this down, but what I'm going to do is go ahead and pull my calculator out, and I've actually already done it once today, but we're going to do it again. And I'm just going to actually put this entire statement, and when I mean the entire statement, I mean this whole thing right here, into my calculator, just like you see it on here. So I'm going to do parentheses. Now, if your calculator has the ability to do fractions like mine does, you can do a fraction there. Or if you can't, you can just say negative 7 divided by 2 in your parentheses, okay? Whether you can do an actual fraction or you use the division symbol, it's still the same thing. So I'm going to square that. Plus 7, parentheses, negative 7 divided by 2, plus 12. Now, when I press enter on my calculator, it is going to give me the answer in decimals, but I do want that in a fraction. On mine, I have this little, if you write under the word answer, you see a little hashtag to a fraction, and if I press that, it immediately flips it to a fraction. If I press it again, it takes it to a weird thing, and then there's my decimal again. So I want my answer as a fraction, so I'm going to put negative 1 over 4. And that's going to be my y value of my vertex, negative 1/4. All right, so again, on the next one, we're finding that x-intercept, which is where we set it equal to 0. So we're going to do 0 equals x squared plus 7x plus 12. Again, I'm going to factor this. You can do the quadratic formula if you prefer that. I'm going to lead off with x and x. Remember to factor. I need it to multiply to the last number, which in this case is 12. I needed to add it to the center, which is 7. So if I think about factors as 12, I've got 1 and 12, 2 and 6, 3 and 4. And if I add this, this gets me 13. 2 and 6 gives me 8. 3 and 4 gives us 7. That's what we want the middle to be. So there's our factors. So plus 3, plus 4. Take each one. X plus 3 is equal to 0. So when we subtract 3, we get x equal to negative 3. And here, we do the same thing on this one. X plus 4 is equal to 0. So we subtract 4 from both sides. And x is equal to negative 4. Remember again, that is 2. One of them is going to be the point negative 3, comma 0. The other one will be the point negative 4, comma 0. Remember, anytime we talk about the x-intercept, it is always a number, comma 0. All right, so the last step in this problem is two things. First, we're going to find 2 points, and then we are going to graph the parabola. So we're going to do 2 things on this one. We're going to find the points and graph. So again, I'm looking at this, and you can go ahead and graph everything we have right now since we do have everything. So negative 7 halves, just so you know, if I'm looking at graphing this by hand, and I know you guys are going to take your test on the computer, but it's always good to know how to do this. We're going to do these as decimals. So this is negative 3.5. This is negative 0.25. So what that means is when I'm looking at my graphing this point, I'm going to go to negative 3.5 on my x, which is going to be halfway between 3 and 4. So 1, 2, 3. And then I'm going to go down just a little bit, and that's going to be my quarter that I went down. And then our x-intercepts were at negative 3 and negative 4. And now I need to pick out 2 additional points. And again, I'm going to be smart about this, and I'm going to choose them equal distance. So I can't use negative 3 and negative 4 since I've already got those values, but I could come here and do negative 2 and then do negative 5. Okay, so those are on equal distance from my vertex here. So I can pick those, and that way I only have to plug in one of them, negative 2, negative 5. So if we plug in negative 2, I'm going to get my equation again. Okay, so q of x equals negative 2 squared plus 7 times negative 2 plus 12. So this would be 4 minus 14 plus 12. So I always like to add my whole numbers together first. So that's 16 minus 14, or 2. So that's going to be 2. That's going to be 2. So I graph those points. I'm going to go to the left 2, up 2, go to the left 5, up 2, and then I have my parabola that I can graph. Okay. Now, when you're doing the 2 points, you can really honestly choose any numbers you want, except for the numbers you already know. So like I can't do negative 3 and negative 4 because we already know those points. But you could pick any other number. I just always like to try to pick one equal distance from wherever my vertex is. That way I only have to technically plug in one thing. All right, so let's look at the next section. This is from section 4.4. All we've got to do on this one is determine the most basic function and then identify the shape. So remember, when you're determining the most basic function, what you're basically going to do here is you're going to eliminate all numbers that are added, subtracted, multiplied, or divided onto your x. So in this case, the only number we're really going to eliminate is this guy right here, the negative 4. And the only thing we have left at that point is x cubed. So that would be my basic function. Okay. So the second one, we just want to identify the shape of the basic function. So just going through the shapes that we have here, just kind of as a reminder. This guy here is our x squared. This guy here in the center is our x cubed, which happens to be our answer on this one. So this is our answer for this guy. This one over here is 1 over x. On our second row, this first one is 1 over x squared. This middle one here is the square root of x. This last one on this row is the cube root of x. Then for the last row here, we have the absolute value of x. And then this last one's our linear function, or just x. So if you don't have those memorized by sight, you need to make sure that you work on memorizing those 8 graphs. Second question, pretty much the same as the first. Again, we want to determine the most basic function. So we're going to come in here and we're going to get rid of anything added, subtracted, or multiplied onto our x. That means we're going to get rid of the 1, the 2, and the -2. So the only thing left is those straight line down. Remember, those are the absolute value sign. So the absolute value of x. That's one of my favorite functions because it's really easy to remember which one it is, because it's a value, so it looks like a v. And that would be this guy right here. That's our absolute value function. Okay. So for that 4.4 section, you just need to be able to identify those parent functions. Make sure you remember how to do all of your shapes. All right, we're on to 4.5. Okay, so in section for this particular question, we want to do our fog and our goff, and then we're going to find our domain. So we're going to use those same questions we talked about earlier. So remember, for fog, we're going to take the g of x function. We're going to stick that into the f of x. So that means we're going to take this guy right here, x, the square root of x plus 5, and we're going to substitute that in for that x right there. So that means that we're still going to have our fraction, and on the top, instead of an x there, we're going to have the square root of x plus 5 plus 3 on the outside over 2. And that's really it. We really can't do anything else with that particular function because the 3 is on the outside of the square root and the 5 is on the inside, so we can't actually add them together. We don't have anything to reduce, so we're kind of done with the fog part. So now what we need to do is the domain. So we're going to ask ourselves those same questions. Is there a square root? Hopefully you're telling me yes. Is there a variable in the denominator? Nope, the only thing in our denominator is the number 2. So we're going to take that stuff underneath the square root. That's the x plus 5. We're going to set it greater than or equal to 0. So to solve this, we're going to just subtract 5 from both sides. So x is greater than or equal to -5. And on our domain, we're going to write it in interval notation. So we're going to do a bracket since we're greater than or equal to -5 to infinity with a parentheses. And again, if you need to, you can draw out the picture for that to make it easier to write in interval notation. All right, let me erase our markings here for a second, and let's do our second step where we're going to do goff. So this time, we're going to take the f of x function, and we're going to stick it into the g of x function. So our f of x function is this fraction x plus 3 over 2. And we're going to come in here and we're going to put it in for that x. Now this is going to take us a little bit more work because we are going to be able to reduce this. I'm going to come over here to the side so we can look at how this is going to work. So I'm going to do a big old square root. We're going to have x plus 3 over 2 plus 5. We're going to want to put that 5 over 1 so we can get a common denominator so we can add these together. Our common denominator is going to be 2. Since he's truly the only denominator we have, 1 doesn't count as a denominator because all I have to do to get rid of it is just erase it. So we're going to have the square root of x plus 3 over 2 plus 10 over 2. Well, now that we have a common denominator, we can add that 3 and that 10 together, and that's going to be our final answer over here. So we're going to have the big square root of x plus 13 over 2. And then we're going to talk about our domain. Again, we're going to ask ourselves, is there a square root? Hopefully you're saying yes. And we're asking ourselves, is there a variable in our denominator? We're saying nope, no variable down there in the bottom. So we're going to take the inside of that guy. So this is going to be x plus 13 over 2 is greater than or equal to 0. To get rid of that 2 in the denominator, we are going to multiply both sides by 2. So now we have x plus 13 still greater than or equal to 0. We're going to subtract that 13 from both sides. So we're going to say that x has to be greater than or equal to negative 13. So when I do our domain, again, we're going to do our interval notation. It's going to start at negative 13 with a bracket. It's going to go out to infinity with a parentheses. And that is our fog and Goff with domain. So again, remember when you're doing the fog and Goff, you always start at the back side of the problem here at the back end, and you put whatever that function is into the front function. All right, question 4.6, or section 4.6 is our next one. We want to find the inverse function. So remember, when we're finding the inverse function, there are 4 steps that we have to take in order to do this. Number 1 is we replace the f of x with y. Number 2, we switch x and y. Number 3, we solve for y. And then number 4, we replace y with f inverse of x. Okay, so that means in this case, we're instead of using an f, we're using a v, but it's the same process. We're going to replace that v of x with y. So we have y equals the cube root of x minus 4. Then we take the y and the x and we switch their positions. So x is equal to the cube root of y minus 4. And then we're just going to go about solving for y. The first thing we need to do is get rid of that 4 since he's on the outside of our cube root. So we have x plus 4 is equal to the cube root of y. To get rid of the cube root, we are going to use the power of 3. So we're going to raise this to the 3rd power, raise that to the 3rd power. So now we have x plus 4 cubed is equal to y. We've solved for y. So then all we have to do is replace that y with our inverse notation. Remember, it's going to use the same letter. So it's v negative 1 of x equals x plus 3, x plus 4 cubed. And guys, when you're doing this particular problem, you do not need to FOIL out the x plus 4 cubed. You can just leave it in that format. I think when you look at the answer key on here, it'll show it all multiplied out, but you don't necessarily have to do that unless you just really want to. All right, so section 5.1, we want to solve by the quadratic formula. It does say factoring on here, but really we want to use the quadratic formula. Again, if you don't remember the quadratic formula, that's going to be x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And I know we've been using this the whole time, so you probably remember this just fine, just making sure we have it written down somewhere. All right, so for our problem, a is equal to 1, b is equal to negative 3, c is equal to 45. So x equals positive 3, because it's a negative and a negative make a positive, plus or minus the square root, negative 3 squared, minus 4 times 1 times 45 all over 2 times 1. So we have 3 plus or minus the square root of 9 minus, 4 times 45 gives us 180 over 2. All right, keep on going. I'm going to bring it over here. So 3 plus or minus the square root of 171. Oops, that was a mistake. It's going to be a negative 171 since it's 9 minus 180 all over 2. Now guys, remember that no matter what happens to the 171, since this is negative, automatically we're going to take out an I. That's for the imaginary part because we really can't have that negative underneath there. But we do need to go ahead and see if we can break up 171. And I know a lot of people are probably looking at that thinking it's a prime number. It's actually not prime. It is divisible by 3. It's going to be 3 and 57. And then this is going to divide out as well. This is going to be 3 and 19. So we do end up having a pair of 3s. So this is going to be 3 plus or minus 3i square root of 19 all divided by 2. And these are our answers right here. We would need to split them up into the 2 different boxes, but that would be our 2 separate answers for that particular one. All right. I think I said we were going to go through 13 tonight, so we'll keep on trucking through these. So here on this one, we're going to use our rational zero theorem to figure out our potential list of zeros. So remember to do this, we have to find our p, our p-value, which is going to be the last number in our problem, in this case 75. And we're going to do plus or minus. We're going to do our little curly Q here. And we're going to go through the factors of 75. So like 1 and 75. And then we ask ourselves, is 75 divisible by 2? We say, no, it's an odd number. And then we say, is 75 divisible by 3? I believe it is. So let's check it out. 75 divided by 3. It's going to give us 25. So 3 and 25. 75 is not divisible by 4, but it is divisible by 5. So 75 divided by 5, it's going to give us 15. So 5 and 15. And it's not divisible by 6. It's not divisible by 7 or 8 or 9 or 10 or 11 or 12. Or 13, or 14, and then 15 is already on our list. So that is our list of possible zeros. And then our Q, remember our Q is always the first one. So in this case, it's going to be 1. So the only factor of 1 is plus or minus 1. And then to find our potential, we do our P's divided by our Q's. So it's plus or minus. Well, in this case, that means that we're going to take this number 1 and divide it into everything on that list. Well, if I divide 1 by 1 and 3 by 1 and 5 by 1, I'm just going to get those numbers again because dividing by 1 doesn't change those values. So our potential list of zeros is going to be 1, 3, 5, 15, 25, and 75. Okay, and that's going to be our answer here for step 1. Now we get the fun job of step 2 of actually figuring out which one of these works. Now, you can, if you have a graphing calculator, use that to your advantage and graph this equation to see which one of the zeros on our list actually works. But you will have to show your work because remember, whether you're taking your test at the testing center, on Zoom, or through the Respondus, you do have to submit your work for your final exam. So make sure that you're showing how you got these answers. So what I'm going to do is I'm going to pull up Desmos. This is going to be my graphing calculator. And I'm going to put this equation in. So x to the third power minus 3x squared plus 25, 25x minus 75. And I can clearly see this 1 0 at 3. So I'm going to use that to be my test value or my my one that's going to get me to the point where I can use, I'm going to use that, my synthetic division, to get me to the point where I can find my other zeros. Okay, so remember our synthetic division, what we do is we put our 3 in the corner. We put our coefficients of our polynomial next, so 1, -3, 25, and then 75. Draw our line, we bring our first one down, and we say 3 times 1 is 3. -3 times 3 is 0. 3 times 0 is 0. 25 plus 0 is 25. 3 times 25. Oops, I forgot my negative on that. 75. There we go. 75. And then -75 plus 75 is 0. By the way, I immediately knew I had done something wrong because I know 3 is a 0. And since I was looking at that thinking 75 plus 75 is not 0, I knew I had written something down incorrectly, which was my negative. I dropped it. So you kind of know if you're using your graphing calculator to work this out, you know 3 is going to work. You know it's going to be an answer here. So if something doesn't work in your polynomial division or your synthetic division, then we go back and check and see what we wrote down incorrectly. Now remember that this is going to be our coefficient to now x squared. The reason being is, remember, I take my power here and I take away 1 power. So since I was cubed, it's now squared. This is going to be our x, and that is going to be our constant. So our new problem here is x squared plus 25 is equal to 0. And the way we're going to solve this is we're going to do a little cheating. You can still do the quadratic formula if you want to, but we're going to use our square root rule here. So we're going to subtract 25 from both sides. And x squared is equal to -25. To get rid of that square, we're going to take the square root of both sides. So our square and our root cancel, giving us x equals, and this is the part you have to remember, there's 2 things on this problem. One is it's a plus or minus. Every time we take the square root of something in a problem like this, we always have to add plus or minus. There's actually 2 answers. And then because this is a -25, our answer is going to be 5i. So remember that negative is what gives us the I there, and then the square root of 25 is 5. So our other 2 answers here are 5i and -5i. And guys, I would almost guarantee that whatever problem is on your final exam is not going to have 3 nice, pretty, rational answers for this, that you're going to either have to use the quadratic formula to get them, or you're going to have to do what we did here, and they're going to be imaginary. So be real careful on that. Know how to do your synthetic division. Know how to solve that second part of that equation, because you're going to have to do that in order to find all of your zeros. So number 13, same type of problem here. We're going to start off by finding our p. Our p is going to be 21. Remember, when I'm doing the p and q, I really don't care about signs. This is plus or minus. Our factors of 21 are going to be 1 and 21, and then 3 and 7. Again, on this one, our q is 1, so our factor of q is just plus or minus 1. So when we do our p divided by q right here, we're just going to get our list, because 1 divided by 1 is still 1, 3 divided by 1 is 3, and then 7 and 21. Okay, so again, let's graph this guy and see where he intersects here. So we've got x to the 3rd power plus 3x squared minus 7x minus 21. There we go. Okay, so we can clearly see a 0 there that's got a really funky, weird answer, and we can see that one's a little bit better, so let's use that -3. So we're going to use -3 as our answer here. Again, using our synthetic division to get something we can work with. So we're going to put our -3 here in the corner. Out to the side, or out beside it, our coefficients 1, 3, -7, -21. Put our line, drop our 1. So 1 times -3 is -3, gives us 0. -3 times 0 is 0, so we have -7. -3 times -7 is a positive 21, which gives us our 0. And we're actually in the same spot we were just a minute ago. We have our x squared, our constant, our x, which is 0, and then our constant. So our equation is going to be x squared minus 7 equals 0. So to solve this guy, we're going to add 7 to both sides. Do it exactly like we did the previous problem. So x squared is equal to 7. Take and do the square root of both sides. Square and square root cancel. So x is equal to, again, whenever you're doing this, it is always plus or minus. We can't take the square root of 7, so we're going to leave it as the square root of 7. So our answers here are going to be -3, the square root of 7, and then negative square root of 7. So again, just like I said previously, most likely the problem that you're going to get on your final, you'll be able to find 1, 0 through your graph, but then you're going to have to find the other 2 zeros either using the square root method or the quadratic formula. They're either going to be imaginaries like they were in question number 12, or they're going to be something like the square root of 7 like we have here in question number 13. Okay, guys, I'm going to do questions 14 through 25 on Thursday, so if you want to join us on Thursday, we'll finish this review off.